Hello, ladies and gentlemen. Welcome back to the VMware Networking and Security live stream. This is where we talk about so many different subjects when it comes to load balancing, networking, security in VMware NSX, all of these different topics. And, the last few weeks, we've been focusing a lot on networking. So we're going to switch it up a bit. We're going to talk about the ALB, which is something that's really exciting. It's a topic I've been wanting to do, and I've been trying to get this guest on for, at least a little bit of time, but he's very busy. But he was able to give us some time, and I'm finally able to bring him on the stream, so I'm very excited about it. Let me bring him without further ado, Mr. Pankaj Gupta. How you doing, Pankaj?
Hi, Andrew. Thank you for having me, and I'm doing wonderful and excited about what our NSX Advanced Load Balancer brings the value to our customers.
Awesome. Excellent. So I like to start out these streams, very simple. So tell me a little bit about you. Where did you come from? How did you get here? And tell us about your history of the ALB.
Sure. So I've been part of the technology for many decades now. I am responsible for product marketing for NSX Advanced Load Balancer at VMware. And load balancing has been very close to my heart, especially the transition to the cloud operating model. So I worked with another legacy load balancer before, and before that, Cisco for a long time, and few startups. So I'm very passionate about how we can help our customers to simplify their infrastructure, the agility they need to roll out the applications faster. And I work very closely with our networking professionals, as well as a lot of cloud architects and CIO.
Wow. Okay. So that's quite a history. So you've been in the industry for quite a while. It sounds like you've had some experience working with a lot of the other different vendors and now obviously here at VMware. So, I think this is going to be a great conversation. We could talk a little bit about history if we like to. But, speaking about history, look, when I was running, a data center and working in many different large data centers, I work with all those different big vendors, the Cisco's, the F5s, the everybody. I work with those load balancers on a daily basis with our application teams. So I know what it's like to be able to work with them. How is the NSX ALB different from all of those load balancers that I used to use, so long ago?
No, excellent question, Andrew. The NSX Advanced Load Balancer, which we call it in a short form NSX ALB, was designed by a startup company called AVI Networks. And VMware acquired AVI Networks for 3+ years. Okay, and AVI Networks or NSX Advanced Load Balancer is a category defining a very modern architecture. And this modern architecture is based on software-defined network architecture, which is just like our NSX portfolio is. To deploy this, you don't require NSX, but it works better together with NSX. I want to clarify for that.
Of course.
And why there was a need for new architecture for advanced load balancing. Let me explain that. If you really look at the load balancing started in early 1990s. F5 introduced Big IP in 1996. NetScaler introduced in 1997. It sounds like 2 decades. But in last 2 decades, lot has changed. There is an emergence of the cloud. There is an emergence of cloud operating model to do things faster, and everybody is looking agility. Previously, you had only handful of application. Now you have hundreds, if not thousands of application in your environment. You want to deploy applications much faster. We live in application economy. Customers are looking for elasticity. Customers are looking at multi-cloud deployment. More importantly, they are looking for automation for that. So these big shifts are happening, and the traditional load balancers, which came out in 1996 or 1997, how many years back? 25 years back?
Oh yeah, I mean, I'm not very good at my quick math, but it's been a little bit.
Yeah. So those architectures haven't changed, and new rules are required. The old rules are not applicable anymore. And that legacy load balancer architectures have remained same. They try to retrofit in it, but they're not good enough for the new need for agility, automation, elasticity, multi-cloud requirement. So let me give you what happened in 25 years back. Palm Pilot came in 1997. Andrew, are you using Palm Pilot?
Not anymore. I just got rid of it.
Okay. I know you are a gamer. You use, most probably you use Nintendo 64 in 1996. Are you using it?
I used to. I still actually have it, but I haven't plugged it in a while.
Okay. Last time when you watched the DVD, which was introduced in 1996, do you still watch DVDs?
Oh man, it's been a while since I've had a DVD now. Now you got me.
Exactly. Exactly. So why customers are really looking to move away from 90 era architecture for that? And that was the primary reason for AVI networks to revolutionize the load balancing for that. Let me give you a little bit more contrast of what is the difference between old architecture versus the new ALB architecture, which we have. Old means that I say the legacy architectures which some of our peers offer. Previously, they were all hardware based. You need a load balancer, you buy a box and you deploy a box. In 3 years, you run out of the capacity, you buy another box for that. It's a continuous cycle of replacing the boxes.
Very big and expensive boxes, may I add.
Yes. Okay. And you have multiple of these boxes. So you have to do a box by box configuration. If you have 100, load balancer, you are managing 100 load balancer. If you have 10 load balancer, you are managing 10 load balancer. And I know some customers have much larger than 100 load balancers for that.
I did. Yes, I know this.
Yes. And that's very complex. And that's the reason NSX ALB moved to a more software-defined architecture where we have a management plane and control plane together into a single instance, and then you have the data plane which can replicate themselves. So instead of managing tens or hundreds of load balancers, you are managing only the 5, 10, 15 control plane for that, and that control plane takes care of rest of the data plane for that. So you can do at least 10x reduction of the managed appliances for that. If I can tell you, Andrew, that I can free up 90% of your time of managing these boxes, I'm sure you have better things to do in the life.
You know, I think Pankaj, so let's recap a few things that you have said, because I think you've said two important things I want to hammer into the audience. And so Ahmad in the chat just said he loves ALB, and we do as well. So thank you. Appreciate that. So I think number one, the thing that you pointed out in the very beginning was the game has changed. The way that apps are developed, the elasticity was one of those words that you use. The way that we approach software development, how quickly it's done. There was nothing wrong with the load balancers of the past, but now that we're doing things in such a different and more accelerated way, we needed a different way of doing load balancing, and that's what ALB provides. And the fact of the matter is like, because the game has changed, we've had to adapt and we've had to do these types of things. And now, you know, another thing that we say is any way that we can optimize our way of operations in a data center. I keep on saying on this live stream, data centers are hard to manage. They're difficult. They become larger and larger. They don't necessarily become smaller. And no matter where you go in the public cloud, the hybrid cloud, the private cloud, whichever you do, any operational efficiencies that you can gain is a definite win in the long run. And it sounds like what ALB gives you is a lot of operational simplicity as opposed to complexity.
Yes. Another big advantage it really brings into that, you're not dependent on the hardware anymore. This is a completely software driven, and I think every CIO or every network practitioner wants to move away from the being tied to the box or chained to the box for that.
Absolutely.
ALB you can deploy on any general purpose server which you have. You can deploy it on a bare metal if you still like boxes. You can run in a virtual machine. You can run in a container. Or if you want to run in a public cloud, you can run it in public cloud. You want to run in a your private cloud, you can do that. If you want to run that in a hybrid cloud, you can run. But the beauty of centralized control plane is that all the policies, all the configuration, everything remains consistent because I know our customers' applications run many times in different data center, different public clouds, different hybrid clouds for that. Managing all that mass is the biggest challenge for that. And that's what the freedom we are offering with this software-defined architecture to not get tied to the box. And
I think the flexibility is such a key thing because, back when I was working with developers and with application owners, one of the big things was they didn't want to be told where to put their workloads. They wanted to choose where their workloads would go and use those tools. And the fact that ALB can be in any one of those areas is such an advantage.
Another thing you talk about the application is that application architectures are also evolving. Previously, most of the applications were in monolithic architecture. Now, with all Kubernetes microservices-based applications coming up, same NSX ALB can be deployed for your monolithic application or traditional application, as well as for microservices-based application. So you don't have to worry about that, I need this load balancer for microservices-based application. I need another load balancer for traditional applications. So we break those silos which still exist today in many of the environments today. Let me give you an example. You look at F5 today. Okay, F5 has been a very respected company, and they are a very respected load balancing company. But having said that, if customers are working with them, they have to go with a big IP for traditional applications, then for NGINX for microservices-based application. And as a network professional, Andrew, you will relate with that you don't want to learn two different things, two different management platform, two different APIs, two different configuration. You don't have to worry all that.
Yeah, you're absolutely right.
That's exactly which we bring in. And the third biggest differentiation which customers really like about us, and this product has been built from ground up for a very end-to-end application visibility. And visibility comes in two parts. One is, can I see all the applications which are being load balanced, irrespective of where they are deployed or what kind of application they are? So we build it from scratch in a single dashboard. You can see all your applications, whether they are monolithic or whether they are microservices based, whether they are deployed in on-prem or different data center or public cloud, you see them. You also see the health of them, that how good they are doing it. And more importantly, we also show you the latency back end to end. So if something goes wrong, you immediately know where the problem is. So the primary reason where our customers buy is or use it is for visibility and the dashboards which we provide for them.
I will say, when in my old company that I was at, what won them over was not only the feature set and how it worked, but that monitoring and that visibility was so key. The fact that they were able to, not only could the network engineers go in there, but we can also have the application owners go in and visually see every single little detail about their application. It blew them away. It literally sold it to them.
Yes. And let's look at a few examples more into that, why we needed a more auto scale or elastic architecture. Imagine you are a retailer. You rolled out a new promotion for Thanksgiving, which is coming, or Christmas, and you are selling, or a e-tailer, you are trying to sell more stuff on that special campaign, or the Black Friday comes in, your traffic to your website or for e-commerce engine is going to increase exponentially. And having a load balancer which can automatically replicate themselves and create more instances for you to create more, to address more traffic, that means book more orders for that. That's an advantage which we bring in. Or you could be a bank. And most of the people access their bank transaction early in the morning or evening after the work for that. At that time, you see a lot of peaks and valleys of the traffic. Nobody can predict their traffic to their application. They have trends, but you can't predict. And that auto scale or elasticity is another bigger the advantage. And that's the reason we see a lot of our customer moving from legacy hardware-based load balancer to this elastic auto scale cloud operating model-based load balancer.
I mean, if we had an uptick of traffic like that back in the day before this, before containers and before, the cloud operating model, you would have to allocate VMs, you would have to allocate, have the operating systems installed, have them configured, add everything into the load balancer, the new IP addresses, make sure that your subnet had enough IP addresses, add it into the firewall, blah, 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 this and the other, where it sounds like if you have the elasticity that you do and the flexibility with ALB, and let's say you can integrate into something like a Kubernetes cluster, it will grow along with your application in those times of stress.
Yes. And you not to wake up at 1 a.m. that my traffic is going and my application experience is going down the drain. It takes care for that. It also have a resiliency. So if one service engine, which is our data plane, goes out, it can take care. So just to bring back that, what actually brings it, it brings really a cloud operating model for your load balancer for that. Okay. It frees you from hardware box limitations for that. It reduces the operational overhead by 10x by reducing the number of devices you are managing. It has a lot of automation built into that. So with this, you can deploy the virtual IPs or VIPs in minutes. Additionally, what happens is that in a typical customer environment, you have 10 to 100 VIPs new deployed every week or every month for that. Each VIP is a ticket, and you have to open the ticket with multiple teams. You have to open the ticket with the IP team. You have to open the ticket with DNS team. You have to open the ticket with NSX team to update their routing tables. And of course, you have to update you have to open a ticket to get the certificates from certificate. So like 5, 6 tickets, and they are all serial into that. And I'm sure many of our listeners or attendees today feel that.
And that's exactly why, from an operational standpoint, things can take months to get through, depending on if it has to jump to different teams, change control approvals, all of these different things.
Yeah. And this is all serial. You cannot provision an application before you get the IP registered in the DNS. You cannot bring the traffic before you configure the routes in the NSX before that. So those are some of the steps for that. So we brought that kind of automation and reduced the steps for these things for that. So that's automation. But there is a much bigger story. Why networking team or cloud teams are deploying load balancer is for applications. And for application, teams are number one stakeholder for any networking team. Okay. And application team opens these tickets with networking team all the time for very regular stuff. Things like very basic things. Create a new VIP. Or my application is not using anymore, sunset the VIP. Or I have a higher capacity now, so I need the more, or I'm seeing more traffic for my application, so enhance the capacity of my load balancer. So these are the 80% of the tickets come in. And of course, my more traffic is coming, I want to add one more server to the load balancing pool. That's 80% of the tickets. Like add the WIP, delete the WIP, add the server, delete the server, increase the capacity of load balancer, or sometimes reduce it. These are the top three categories, like add or delete WIP, or add a new server, delete, or enhance or reduce the capacity. Those are things, 80% of it. What if you empower your DevOps team or the application teams to do these things by themselves through a self-service portal? Of course, for exception cases, they can open the ticket with you. And that is one of the biggest advantage which we see in some of our largest customers, including the banks, because today the banks are virtual, banks are digital, everything is on application on that. And their rate of innovation of new features is pretty fast. So they have improvised, they have empowered their application team through a self-service model through ALB for that. So for basic things, of course, there will be 20% corner cases for which you have to open a ticket for that. So that's a huge empowerment. Let me bring back to that why legacy load balancers couldn't do that. There are two things. First is these load balancers or legacy load balancers were designed in 1996, 1997. They were not really designed for multi-tenancy. They didn't have a very strong RBAC built into that. And there was a concern that if one rogue application developer can mess up something, it will bring down all my applications. So NSX ALB took a bottoms-up approach from day one to make a very strong multi-tenancy model. So impact domain is much, much smaller for you. So Andrew, you are an application developer, you mess around your application, but the remaining company's applications keep running for that. That is another big differentiation or the value which we bring for customer for the self-service model. And of course,
I think yet again, just to say, like, the game has changed. And back in the day, for better or worse, a lot of these things like the load balancers, the routers, the switches, the firewalls were behind lock and key by trained individuals and certified individuals. And we never even thought of handing the keys of the castle over to the application teams, the development teams. That's why you had us. But now with the speed of development, not only do they want to be able to have resources inside the infrastructure allocated faster, but they want control of their destiny. And that's why the RBAC is so important. That's why the visibility is so important. That's why handing them the keys to the castle responsibly for their application, so that way they can increase their resources, they can add their stuff without affecting somebody else on, let's say, a legacy old shared load balancer that the configuration could affect everybody.
Agreed. You are spot on.
So let's talk, Pankaj, a little bit about you brought up a very unique term that I want to explain to our audience that may not be so familiar with ALB. You brought up the service engines. That seems to infer that there's some type of controller as well. Could you explain a little bit of the architecture of how ALB works and what makes it so versatile and expansive?
Yes. So maybe seeing is the believing. Let me see if I can pull one slide quickly.
Sure. And while Pankaj is bringing that up, remember, ladies and gentlemen, the viewing audience, you are more than welcome to ask any questions. Pankaj has a wealth of knowledge. So if you have any questions about it, about ALB or the product itself, hey, send it his way. He knows his stuff. So just to while you're bringing that up, oh, here we go. Perfect. All right, let's add that to the stage. Here we go.
If you want me to make it bigger, I can certainly make it bigger.
Oh, I think this is perfect. I can see it quite nicely.
So what you see over here is a control plane, which is a set of controllers. Typically, we recommend 3 controllers, and these controllers are managing all the data planes. So control plane is basically has a visibility of all your centralized policies, centralized management, and also checks the health of all the service engines, which is basically the data plane which you see here. And one controller can manage multiple sets of the service engines, which is basically the data plane. And these service engines or data plane are responsible for load balancing your application. And these service engines can be auto scale here. So if you see more traffic coming up, controller knows that this service engine is running out of the capacity. It can duplicate another service engine and add more capacity for that and keep the policies consistent without any human intervention for that. So that's one benefit. The second thing is that I talked about the vicious cycle of software upgrades of 100 load balancer. If you have 100 load balancer, you start updating one, the next day you update the second one. So you do a continuously software update cycle for that. Here, we are reducing that software updates significantly because you just update the controller, and with that, it automatically updates rest of it. So you reduce those upgrades time and vicious cycle, that continuous upgrade cycle for you. Third thing which we also bring with this architecture is that we can load balance traffic between these service engine as we do the auto scale also for that. And if controller also monitors the health of individual service engines here, and if one of the service engine get disconnected or has issues there, it can easily transition the traffic from that service engine to other service engines for that. So it brings a lot of resiliency for that. And for resiliency, if you're wondering that is controller is a single point of failure, absolutely not. You can have cluster of 3 controllers, so it gives you one-to-end redundancy. If one goes down, the second can take over for that. So that's a simplified way of looking the control plane and the data plane, and you can deploy it in a virtual machine, you can deploy in a container, or you can deploy in a bare metal, and of course they are supported across on-prem, private cloud, VMware cloud even, or even the native public clouds for that. And if you have applications in a multi cloud environment, we also offer a cloud console which allows the visibility and management of controllers which can span across multiple places for that. So that's a basic architecture of NSX ALB, and you see very clearly it is a software-defined architecture, and you can run this on any platform. We are not tied to any specific hardware.
I think what's interesting about this is the fact that, just like how the game has changed when it comes to software development and using containers and expanding things quickly, so is the architecture of the AOB and the service engines. If you need to increase it, it will do it automatically. You'll be able to scale those things out. You'll be able to move traffic between the service engines if needed. You have a separation of the control plane, the data plane. It's literally doing real world brand, newer architecture of design, and you've implemented it directly into the product itself. So one elephant in the room. So, as we have said here at Pankaj, it could be very difficult to manage a data center or to migrate over to a different, thing like, moving up from one load balancer to another. Let's say there is a certain type of vendor lock-in or so, or they have like a tremendous amount of iRules or so like that. How do you approach that and move that over to ALB? Is it able to do the same kind of things? Explain that.
Agreed. I think it's a great, very important question which we hear all the time from our customers. Okay? Just to give you a few examples for that. Each customer journey for load balancing transition from legacy to a modern load balancer like ALB is different. Most of the customers start with one or couple of existing applications. And to choose the application, typically for a new application which they have just developed, or an application for which they have a less traffic or less strategic importance to begin with. The reason for that, IT team always extremely cautious for all the right reasons to test the product and make it sure that they feel comfortable and they do their own testing for it. So for transition, we really recommend our customers that start with a couple of applications, most probably a newer application or an existing low priority application. So you get to know the product, learn all the whistles and the knobs to tune around and see the value of the product first. And for our customers to bring the value of the product, we offer architectural workshop, the two variants. One is the Architecture 101, which is a 90-minute workshop. You will get to learn all the capabilities for the of the product in a quick 90-minute. And you not to pay for anything. And we run every month one architecture workshop for 90 minutes. Sometime we post the recording and you should be able to feel comfortable. Second part is that we do a very detailed 4-day, half-a-day workshops for that. And then you learn each and everything, the best practices, how to fine-tune the things, what are the benefits, what are the 10 features you should get the benefit out of. So we run those architectural workshops for that. Even if you don't attend all 4 days, which are 4 hours each, if you attend first and 2 days, you will see the value of the product for that. We really want you to attend all 4, but even if you can't do it, attend at least the first day or second day to what this product can do. And this is all free, available on our website. You can go to the VMware website to get more about it, or you can go to AVI Networks. If you are an NSX a user or a VMware existing user, you can go to Tech Zone. We have a brand new page there. We can find all of how-to videos. We have more than 100 how-to videos for that, so learn from it. So that's a first piece. We help our customers to start with a small project. Within 3 months or so, you will feel comfortable. You see the value of that. And then you plan a journey to bring the remaining applications from F5 or Citrix or other legacy load balancer to the ALB for that. Most of the customers who use the iRules, they feel locked down into iRules. Let me give you a little bit more background on iRules. iRules were introduced around 2004. At the time, load balancing was pretty new. And HTTP redirect or content switching was very cool technologies. But to do that, you require TCL scripting skills. And I'm sure network team will pretty smart and good, but they really don't really enjoy writing the technical scripts for that because
boy, they did not. I can tell you they did not.
Okay. So those are some of the challenges with it. Requires a tackle scripting skills. If you do a syntax error, the whole load balancer goes down. You have to do the testing of it. Every time you do a software upgrade, you have to do the testing again, and they are hard to troubleshoot. But this is not just a one-time activity. As you know, in IT, you hire the intern, people switch the teams. These iRules over a period of time, they become the black box because nobody remembers what iRule was written and what it is for. And I can guarantee you nobody knows that what is there inside their iRules. So
legitimately, there is so many times, Pankaj, that I have logged into a load balancer in an F5, and someone from the network team from 10 years ago that already left the company wrote that tickle script and put it in there and never touch it, because if they break it, they don't know how to troubleshoot it.
Exactly. And what customers tell us is that iRules always grow, they never shrink. I will repeat, iRules always grow, they never shrink. If the audience feels that, just say yes in the comment, or give a thumbs up to us, so we see that do you feel the pain for that. Okay.
Oh man, that is so true. That's a great statement there, Pankaj.
Okay. So we respect iRules. They were great technology in 2004. And I think market has realized that. Even NGINX from same vendor F5 doesn't have iRules. Volterra, even from F5, doesn't have iRules. Citrix doesn't have iRules. Of course, we do not have any iRules. If you want to write a script, you can, of course, write a script in Lua for a very complex configuration. But 80% of the iRules which you have, we are enabled by default, or just simple click, 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 click. You don't require a skill set for tackle scripting. So 80% of iRules you can take care by just default configuration, or by just point and click in our UI for that. So that's what the very, very simple for that. For some customers, it may take a little bit of time, a little bit effort, but if you want to be debt free, you have to take some extra effort for that. We have seen customer two approaches for us, or for themselves. One is, I had this technical depth of 10,000 lines, and I want to understand and translate and take it to the new environment. So you are taking the technology depth with you to the new environment. It may not be the best strategy. Our smarter customers like to listen, okay, I had enough with this. I'm going to start fresh. I'm going to see what configuration or what algorithms or what rules I require, and I will configure through UI, and that's what the ALB really gives into that. So we see customer of both kinds in the market, but you have to do the evaluation. Our recommendation is that start fresh, start sync for your policy configuration. If you still want to continue with your existing policies and the thing, and you have a good visibility that what 1,000 line code is really doing for you, then we offer professional services to help you. We offer some tools which helps you to configuration, and we are investing more into that. You might hear in coming days for that. So those are some of the strategies and frameworks which we hear from our customers for that. Let me give you one example for that. We were working with one of the top US banks, and they are in the Fortune 50 banks. They have deployed around 20 controllers for that. They have migrated 5,000 VIPs into that, and their speed of migration is 200 plus VIPs per month for that. They are running more than 2,000 plus services for GSLB, and they have 700 plus tenants for that. So if you're really looking for a automation scale, that's what this product. If you are nervous about how transition is going to be messed up, 80 to 90% of our customer are our existing legacy load balancer customer who are migrating to the ALB. So it's not a rocket science. It just requires a little bit planning properly, and of course, a little bit of extra effort, but VMware is there to help you in this journey.
What sounds like to me is like, yet again, as the theme of this whole live stream about the ALB is highlighting the fact that we're trying to get people away from what could be lock-ins or technical debt, because that is our constant deal that we have to work with, as data center administrators, is trying to get away from technical debt and trying to make our lives easier and make our customers, or in this case, the application developers and owners, their lives easier, and be able to easily operate this thing. And you can't do that unless you release yourselves, like you said, from the chains of the old technical debt and move yourself into new cloud-based operational models that are much more scalable and much more versatile when it comes to their RBAC and their automation capabilities. So the game has changed, and you have changed it with this product.
And this automation hasn't stopped by product itself now. So we are very deeply integrated with our NSX networking stack. We are integrated with vSphere. We are integrated with Tanzu if we are using for microservices-based applications. We are also integrated with OpenShift. We are integrated with Rancher. We are also integrated with Amazon EKS, also AKS, and also GKS. So any variant of Kubernetes-based environment you can think of, we are integrated. We are integrated with Varni. We are doing more integration with VRA. So almost every VMware product you can think of, we are integrated. The integration brings two things for you. One is the more holistic automation, so make the workflows easier for you. And the second one is the visibility for that. If you combine the NSX with NSX ALB, NSX networking with NSX load balancing, you have a visibility for the full stack from layer 2 to the layer 7. So you can troubleshoot the problems faster for that. This is about the product integration. We also integrate with some of the biggest VMware software stacks. One of them is VMware Cloud Foundation. Second one is the VMC. Similarly, for VCPP customers for that, we are also integrated with the Telco Cloud for that. And I want to bring one point back about the VCF. VCF is a great platform, and we are very thankful you are using for building your private cloud. But when you add the advanced load balancing on top of it, the VCF evolves or upgrades from an infrastructure platform to an application-aware infrastructure platform. And it gives the visibility which every networking or VCF admin really requires, that how my application is mapped to my network, to the servers, and rest of the networks for that. So that's one of the very, very key value add. And if you are not using VCF environment, you still get a lot of benefits which we talked about it.
Pankaj, like one of the favorite things that I've done, and luckily, working here at VMware, I get the opportunity to be able to work with a lot of our different product lines and a lot of different customers in my own lab, which I've shown on the live stream many a times. I have my own Kubernetes environment. I integrated that with ALB with the plugin that goes in with it, and then on top of that, have that integrated obviously into NSX. And there's something cool about writing a microservices architecture, a program, and writing that out, creating the load balancer. I can deploy it with Terraform or whichever, like VRA, VRO, whichever format I want, and then it just shows up. The VIP shows up in ALB. It creates all the different pool members from the containers, and then I can create security policy and then NSX. That's just so cool. Like the dork in me just loves that I can do all of that. And really, I mean, we weren't able to do things like this 20 years ago, make a private cloud in your basement. And I have the ability to be able to do something like that.
Yeah. No, you can deploy in private cloud, you can deploy in hybrid cloud, you can deploy in multi-cloud, you can deploy on any hardware platform you like, you can deploy for microservices-based application. You can deploy for monolithic applications. You can enable self-service for that. and the flexibility. But I want to take away three things. What it really brings is a lot of automation for you. Second one is the very deep visibility about how to troubleshoot the things. And the third one is integration, which we offer with the VMware stack for that. I strongly encourage each of the attendees today to attend one of our architectural workshops. You will get a lot of insight, and that is not the marketing workshops. They are the deep technical workshop. You get a little bit of hands-on experience. You get to see product into the action. Or if you don't want to wait that long enough for the next webinar this month or next month, you can always go to the techzone.com and you will see a lot of how-to videos so you can see the product in action.
I actually added into both the Twitch and the YouTube chat the Understanding VMware NSX Advanced Load Balancer on the nsx.techzone.vmware.com. It is a fantastic spot. Like Pankaj says, there's just a tremendous amount of data where you can find videos and tutorials and learning material out there to be able to understand exactly how the ALB works and how it integrates with everything. I swear, Pankaj is true. It integrates with everything. I think it actually almost integrates with my drum set. I think you guys made a plugin for that, so I can expand it and contract it and at will.
And Andrew, you brought a great point that how do we integrate? The engine behind or the base capability for our product is API first. So there is nothing which you cannot do without API in our product. So every feature, every functionality we have exposed through APIs. So that's a reason for us to integrate with any product, including even Terraform or Ansible you are thinking about, or Prometheus of Grafana, or even Istio. We are integrated with those for that. So we have invested a lot of time for opening the APIs.
And I think that's such an important thing because, yet again, back in the day, because the game has changed, everything that you put in your data center should be API first. Everything that you work with should be some type of API interaction because that's how you bring out efficiencies. That's how you write code around it. The fact that there is nothing that you can do in the API that you can't do in the GUI and vice versa, that is super important. And I think we kind of lose track of the fact that that was not true 15, 20 years ago. And now we're living in this brand new world where you're able to do everything in an automated infrastructure as code, self-service manner. That's huge.
Exactly.
Well, Pankaj, I want to thank you so much for being on this show. It is fantastic that you come on here to lend us all of your knowledge and the history and understanding. I would love to have you back on this show to get a little bit more in depth on different areas of the ALB and more of those use cases, because I think that really resonates with people that are watching, and it gets them thinking about how they can integrate it within their data centers and move their workloads over. So thank you so much for your time. Any closing thoughts before I let you go here?
Thank you, Andrew, for having me for this discussion. I think load balancing market is in the time of transition where it has to get ready for a faster deployment, the agility which every application developer is looking from the networking or the cloud architecture team today. And I strongly request our audience to attend one of our workshops. Maybe start with a 90-minute architecture 101 workshops, or if you want to attend the 4-day architecture workshop where you get the more deep insights, or otherwise call your sales rep and they will be happy to work with you to walk you through how they can make your fleet of hardware-based load balancers simpler, easier to deploy, manage, and unshackle from the burden.
Thank you so much, Pankaj. Stay on the line. I'm just going to wrap up the show, and I'll be right back. Ladies and gentlemen, thank you so much for joining the VMware Networking Security live stream. As always, we appreciate your questions and your comments. We appreciate you just sitting here and viewing. We know that it's, you have a long work day and that you have a lot of things to do, and you spending time and wanting to ask these questions and understanding really means a lot to us. And it makes us want to keep on doing this. So thank you so much for your time. As Pankaj says, go check out the Tech Zone. Go check out all the different classes that we have, all the tutorials and all the videos. If you want more information, talk to your TAM, talk to your accounting, talk to people, and you'll get guys like me and so many others, guys and gals that work over at VMware that are so knowledgeable on this stuff. We're here to help. We're here to make your lives easier. Thank you so much, and we'll see you next time on the live stream. See ya.